I'm presenting on my final year project, which is on energy data management. Basically, what that means is I was using signal processing data. I was using signal processing knowledge as well as machine learning algorithms to classify the appliances that were in a given data set that I was using. So the motivation for this project is to reduce the carbon footprint in electricity production. Increase in population and advances in technology have resulted in an increase in the demand for electricity. Back in the day, the way energy companies would solve the problem would be to build more and more power stations, but in this day and age, that is no longer a viable solution. Instead of building more and more power stations to cope with the demand, existing stations can be optimized and managed better by giving energy consumers information about their energy consumption behavior. This information can be gathered by utility companies and provided to customers in the form of itemized bill, which shows the consumption in the energy or household of each appliance. This may also result in cost-saving benefit for the customer. When the demand decreases, the production also decreases, which will also reduce the carbon emissions. So one of the ways which is used by utility companies to gain this information is through a process called intrusive load monitoring, where multiple sensors are put on different devices which consume electrical energy to measure their energy consumption. The disadvantages for using this method, it uses expensive and very complex hardware, and also installing the sensors on every device is difficult as well. And also routine maintenance and upgrades pose a problem for the customers, as it may be intrusive as the utility companies regularly come to the customer's house. When the hardware becomes obsolete, it needs to be upgraded, and it is an expense on the side of the utility companies. An alternative to non-intrusive load monitoring is what is known as non-intrusive load monitoring, which uses complex software, but then instead it uses simpler hardware. And the advantages of intrusive load monitoring are that there's no intrusion to the customer's homes except during upgrade and configuration. And it is also a low-cost solution. And then software can be easily dispatched to the customers remotely. The aims and objectives of the project is to identify a data set used for training and classification of the model from the publicly available data sets, develop a pre-processing for the current and power signal, and then create spectrograms, images for the appliance classes, and then extract features from images using. So here it was supposed to be using convolutional neural network, which is the ResNet 50 model, and then classify them using a support vector machine, and then train the load identification module in this case, which is the support vector machine, and then test the module for correct identification of devices, and then develop user documentation. In this diagram, I've shown that the data set, which is basically a summary of the data which I've used, which is known as the plug load appliance identification data set, or commonly known as plate data set, which has 11 appliance classes, and this data was recorded across 55 different houses in Pennsylvania. But at the right end, I have the current signal as well as the voltage signal right below it. Basically, these are instances of a laptop, which I've just shown as an example. Right here, I have the sort of like the process flow for extracting the files, as well as creating an instance of the sort of like a variable of the first device. So here, if you're using the current method, which is on the left, then you would start off by reading the CSV file, which contains the raw data, as well as the loading the JSON files which contain the metadata. And the goal is to combine these files so that you have the appliance type, as well as its current signal measurements, as well as other variables that define the same appliance. Similar approach is taken for the power signal, but instead we have power being calculated by taking the voltage and the current and multiplying them together. The appliance instance that is obtained from the previous from the previous process flow is fed into this process flow is on the left side of this diagram as input to this, and then it's used to plot the spectrograms. And then we have a decision here. So the one that falls through below says if appliance type directory exists. Then if it doesn't exist, then it would go to this block which says create new directory. If it does exist, then it will move to get current active figure and save this spectrogram as images, and then it would move it to its specific directory. Right here on the right, I have the program flow chart for the classifier. Basically, what it's doing is taking the output, which is the stored spectrograms from the previous process, and then it splits the data into 70% training and 30% test, and then it resizes the data, both test and training sets, such that the size of this are the same as the input size for either the convolutional neural network or the ResNet 50, which was used for feature extraction and training with a support vector machine. And after that, they are thrown to classifier, and the classification parameters are defined by one of the blocks at the top. As output, you get the mean accuracy as well as the confusion matrix, which is used to calculate the metrics which are used to benchmark the performance of the system. As an example, I've extracted three appliance classes: the fridge, the microwave, and the washing machine. So basically, I've shown the difference between current signal and the power signal, and horizontally, I've just shown the current signals, and at the bottom, I've shown the power signals for different appliances. Engineering decisions made. So the main decisions that were made during the project revolved around efficient utilization of the computer hardware resources. Instead of loading the whole dataset into the memory, one file is loaded into the memory at any instance, processed and overwritten by the next file. When the spectrogram image is created, it is moved to its respective appliance. So basically, it's just trying to free up as much memory as possible for the next process to be as efficient as possible, and also developing modules to read files instead of waiting for data that is part of the. So I used bottom to top, sort of like a modular design approach. And because I didn't have the data at that time, because the website that I was getting the data from was not working, maybe it was under maintenance, started to develop other modules that I thought they were independent of whichever data I was going to use in the end. And also using the CNN for feature extraction, because of this layer depth, it allows it to extract very rich features compared to manually selecting the features. Coming to the results, these bar charts are showing the performance evaluation in terms of F1 score and accuracy of the support vector machine using different kernel function polynomial, but with different polynomial orders. So the first one is the linear solver, and the next ones are second, third, and fourth orders. And we can see clearly from the bar charts that the best performing polynomial was the polynomial order 2 with the classification accuracy of 84.93%. In the next experiment, I only managed to compare the mean accuracy, not the F1 score and other metrics because of accuracy. And in this, I was comparing the performance analysis of the RB kernel versus the Gaussian function. And the RB kernel was the better performing of the two with an accuracy of 85.13%. So it was carrying out this experiment. The box constraint was varied as shown in the chart, which is 1, 5, 10, 20, 50, and 100. And also the kernel scale was kept to constant. Yeah, this was an error. This was supposed to be comparison of current training feature versus power feature, and is highlighted here. We're comparing the power signal and the current signal. So overall, the best performing is the power signal with the CNN with the and the number of epochs equals to 30, and it can be seen from this graph that as you increase the number of epochs, the performance starts to degrade. And coming to the next one is on future work. So the accuracy can be enhanced in the future development of the project by exploring the effects of using different windowing functions and window length. Another approach for consideration is to combine the power and the current signal spectrograms as an alternative to the fast Fourier transform, which was used with the spectrograms, would apply maybe discrete wavelet transform to the signal. And also the other thing was testing with a larger number of appliances would be required to test the method's robustness as the number of appliances increases. Potential environmental impact. People will get a better understanding of their energy use and its impact on the environment, which is also like kind of the thing that happened when people started to understand the effect of the plastics that they have in the impact of plastics on the environment. They started to take a positive approach on reducing their usage and disposal of plastics. Less frequency cutting down on vegetation to create right of way for new power systems. So whenever a power station is created, trees are cut down, vegetation is destroyed to create roads for excavators and pylons to be set up. If customers wish to reduce their energy consumption, they will likely buy energy efficient appliances. As a result, this will also have a positive impact in the sense that manufacturers will be forced to sort of like design appliances which are energy efficient. Benefits to society: reduction in intrusion of or into people's private utility companies, and also cost saving by reduction in appliance usage, which is estimated to be around 20%. And then another one is also economic growth and as a result of optimum utilization of electricity. And other one, which I did not include on this slide, was related to the previous slide on vegetation. So since less vegetation is destroyed, people can benefit from that environmentally. This is the end of my presentation.